Let's take a look at the oxidation states for each element here in HOF. This is hypofluorous acid. We have our hydrogen, our oxygen, and our fluorine. So to figure out the oxidation states, this one's a little tricky. We're going to use these rules here. So based on the rules, we know that this is a neutral compound. It doesn't have a negative or a positive charge. It's not an ion. So when we have a neutral compound, all the oxidation numbers, they need to add up to 0. So keep that in mind. Hydrogen, when it's bonded to a nonmetal, that's going to be +1. So we have +1 for the hydrogen here. Oxygen, that's normally -2, except when it's bonded to fluorine, and then a few other instances. So we're really not sure what oxygen is going to be. Let's just call that X. And then fluorine is -1. So we can see the only way that these numbers add up to 0 is if oxygen has an oxidation number of 0. +1, 0, -1, that adds up to 0. Since we have a neutral compound, they all add up to 0. This does make sense. Oxygen is more electronegative than hydrogen, so hydrogen should have a positive oxidation number here, and then oxygen is less electronegative than fluorine, so it makes sense that fluorine has that -1 there. There are older definitions that might give you a different answer than this, but this is the one that makes the most sense, and it's based on the most recent definition of how we assign oxidation numbers. This is Dr. B with the oxidation numbers for HOF, hypofluorous acid. Thanks for watching.